So here's a problem. If we have a positive integer, say 10, and we want to break it into the sum of consecutive positive integers, say 1 plus 2 plus 3 plus 4, which is 4 pieces. Notice that 10 can't be broken into 3 consecutive positive integers. 2 plus 3 plus 4 is too small, and 3 plus 4 plus 5 is too big. How can we tell which number of pieces a positive integer can be broken into this way? My name is Dirdos. I'm on a mission to collect interesting math problems for school-aged children, and I'd like to take you along. Trying to break numbers into the sum of 2 consecutive integers already gives us a pattern. This seems to work for all the odd numbers, but not the even numbers, which makes sense since between 2 consecutive integers, one of them must be odd and the other must be even, so the sum must be an odd number. For the sum of 3 consecutive integers, only multiples of 3 seem to work, and the pattern continues for other odd numbers as well. For a number to be broken into the sum of 5 consecutive integers, it has to be a multiple of 5. For the sum of 9 consecutive integers, only multiples of 9. This makes intuitive sense since the integer in the middle of an odd number of consecutive integers is the average of those numbers. To calculate the sum, we can make them all equal to this average by taking bits from the larger ones and giving them to the smaller ones. The average, or the middle number, should also be equal to the sum divided by the number of pieces, which means the sum has to be a multiple of the number of pieces. Things get a bit messy when we try to break numbers into other even number of consecutive integers. A number can be broken into 4 consecutive positive integers only if it's even, but not too even, as in not a multiple of 4. For it to be broken into 6 consecutive integers, it has to be a multiple of 3, but not 6. This also makes sense if we think of the consecutive integers in terms of averages, because an even number of consecutive integers don't have one middle number but 2. Their average must be between the 2 middle numbers, i.e. not an integer. This means that sum divided by the number of pieces is a decimal that ends in 0.5. So the sum must not be a multiple of the number of pieces, but it must be divisible by all the factors of the number of pieces except the last factor of 2. There are also multiples of numbers of pieces that don't work because sometimes we run out of room in the positive integers. For example, to write 5 as the sum of 5 consecutive positive integers, the middle number has to be 1, which means we'd have to go into the negatives to get all 5 of our integers. Similarly, if we tried to write 4 as the sum of 8 consecutive integers, the average between the 2 middle numbers is 0.5, and the left side will have to extend into the negatives. What happens if we remove the constraint and let it go into the negatives? For the case of writing 5 as the sum of 5 consecutive integers, the integers we get would be -1, 0, 1, 2, and 3. If we tried to add them, the negative would start to cancel with the positive, leaving only 2 plus 3. Did we see that before somewhere? Way back in the beginning, where we tried to write 5 as the sum of 2 consecutive integers. For the case of writing 4 as the sum of 8 consecutive integers, we get -3, -2, -1, 0, 1, 2, 3, and 4. Canceling out the negatives and the positives would leave us with just 4, which is the way to write 4 as the sum of 1 consecutive integer. Does this happen with every possible way to break down the number? If you're enjoying this problem, I made it into a book, so you can share it without giving away the solutions. Check out the link in the description below, and back to the video. Let's try with 10. To write it as the sum of an odd number of consecutive integers, the average must be an integer, so the number of pieces must be a factor of 10. Our possible choices are 1 and 5 here, which gives us just 10 and 0, 1, 2, 3, 4. To write it as the sum of an even number of consecutive integers, the average must end in 0.5, which means the number of pieces must have one more factor of 2 than 10 in its prime factorization. Since 10 has one factor of 2, the number of pieces must have 2 of them and as many of the 10's odd prime factors as we like. Our choices here are 1 times 4, which is 4, or 5 times 4, which is 20. And the lists we get are 1, 2, 3, 4, and this long one from -9 to 10. If we take away the zeros and cancel out the positives and negatives, these two are the same, and these two are the same. These lists come in pairs, and only one of each pair is made up of all positive integers. Notice that the pairs are always made up of an odd number of consecutive integers and an even number of consecutive integers. This is because when canceling out the numbers, the positive and negative numbers always come in pairs, and there's always an extra 0, so we're always removing an odd number of integers and switching the parity of the total count. This means we can find out how many ways a number can be broken down like this just by counting the odd number ways. Let's try another starting number, say 15. The odd factors are 1, 3, 5, and 15, so those are our starting cases. And we should end up with 4 different ways of writing 15 as the sum of consecutive positive integers. Without going through the trouble of writing out these lists, we should be able to tell which ones would go into the negatives by looking at the averages. There should be enough room between 0 and the average to fit the bottom half of the list. 1 and 3 are easily in the clear, and we can barely fit it in for 5. It doesn't work with 15, so we'll end up with an even-numbered list here instead. How can we tell how many integers would be left in this even-numbered list though? Since the average here is 1, notice that we'll always have 2 more positive numbers than negative numbers, no matter how far we stretch in both directions. When we cancel, we'll always have 2 numbers left. If we try this with different averages, we can see that the number of positive integers left is always twice the average we started with. This way we can tell which lists we'll end up with without going through the trouble of listing out any of the lists. Try this with a bigger number, say 81. The odd factors are 1, 3, 9, 27, and 81. The first 3 will give us lists that are entirely positive. With 27, the average is 3, so when we cancel, we'll end up with 6 numbers. With 81, the average is 1, so 2 numbers. Put it together, and we have 81 can be written as the sum of 1, 2, 3, 6, or 9 consecutive positive integers. Phew, math makes sense again. Now I wonder what happens if we try to write an integer as the sum of consecutive odd numbers or consecutive even numbers. Let me know what you think in the comments below, and until next time, stay curious.